Good morning, everyone.
Hello, everybody.
Hey, Jeff.
Hey, sorry it took us a minute to get set here. Thanks for joining us, though. Welcome. Let me put this away so it doesn't interrupt your screen. Welcome to our virtual conference here. We get the first session, Annie, today about addressing, practical guide. A little bit of housekeeping for everyone. We're going to keep everyone muted for the ability to just keep things going. But there is a Q&A panel that if you want to ask a question, and we encourage you to answer them live, use the Q&A panel to ask a question, and we'll be monitoring that as we move through today. So we appreciate your joining us today, and we look forward to sharing some information with you and holding value for you. So let's get started. First, actually, let me introduce myself. I'm Jeff Ledbetter, and I am a public safety GIS expert here at Datamark. I've spent more than 20 years working with GIS technologies and 10 or so of it in public safety and addressing spheres in a municipal setting. And I'm glad to share some information with you today about that. And I have with me my co-host, Annie Cahill. Go ahead and introduce yourself, Annie.
Hey, good morning or afternoon, everyone. I'm Annie Cahill. I am a public safety GIS technical manager, and I'm also a project manager on several projects in the U.S. with Datamark. I have about 15 years of experience working in local government dealing with GIS and address management, and I'm really excited to be here and talk to y'all. So thanks for joining.
All right, let's get started. Just a few items we're going to talk about today. Just to tell you right up front, this is actually a 4-hour workshop that we do that we've kind of trimmed down to an hour because there's not going to be a lot of back and forth from the audience. But again, we encourage you to answer questions in that Q&A. But we're going to talk through the history and legacy of addressing, the anatomy of addressing, managing addresses in GIS, and then we're going to share a case study with you of master address databases. So just a quick quiz that we like to do at the start of this to just kind of level set a few things and get into the topic. First question is a statement, so I'm going to ask for a true or false answer. You don't have to actually answer, but we're gonna level set with that. Addressing is a function of the U.S. Postal Service. What do you think, Annie? Is addressing a function of the U.S. Postal Service?
Yeah, sure.
This is one of my favorite soapboxes to stand on, actually, is that this is not a true statement. It is not a function of the U.S. Postal Service to address structures or land or anything else. The U.S. Postal Service business purpose is to deliver envelopes and boxes to post boxes. They do an excellent job of that, and they use addresses in order to accomplish that. But addressing is a function of the local government. Oh, I gave you the answer right out front, didn't I? An address can be assigned without a quote-unquote structure present. I've been a part of many debates on NENA working groups where this is the prompt for discussion. An address can be assigned without a structure present. Now, what is the definition of a structure? Does it have to have doors and windows to be a structure? Could it be a power transformer for emergency power to traffic lights? Could it be a power pole, perhaps? But addresses can be assigned without structures present. And that's basically what a situs address is. Third, addressing is a mission-critical function for all government. Let me read that the way it is written. Addressing is mission-critical to all government functions. I say true. because all government functions, maybe almost all, pretty pervasively, are point of service deliveries, right? There's services delivered to a place that is within that jurisdiction. And so addressing is mission critical to all government functions. Subaddressing isn't that important to maintain. I say false, because subaddressing increases precision, increases accuracy, not just in the GIS sense, but the precision and accuracy of locating functions and structures and buildings and things like that. So let's talk a little bit about the history and legacy of addressing. It's a pretty interesting topic. You know, back in the days in feudal Europe, cities began to emerge, and people lived closer and closer and more density. They wanted to get around, and they needed directions. I'll meet you over at the Fox and the Hound for a pint. Give directions, saying things like, turn left at the Windy Mermaid and then right at the Broken Wagon. They set about to putting ornamentation on their structures, as you see in the pictures here, that were either signs, functional signs, or ornamentation to say, oh, it's the building with the golden apple over the door. Then as things progressed and governments needed to collect taxes better, conscript armies, and conduct censuses, the need for addressing became stronger and stronger, and systems began to develop. As I mentioned earlier, all government services are point of service delivery, along with things like the Pony Express, the USPS, when you need that pizza, when you need a ride from Uber and Lyft. Public safety is certainly a point of service delivery, school bus pickups, etc. This Pony Express sign is a great one. It cracked me up when I found it. It says, wanted, young, skinny, wiry fellas, not over 18, must be expert riders, willing to risk death daily, just to find those places. Orphans preferred. That's pretty harsh. So these systems began to sprout up and evolve. How do we track the location of given plots of land that we want to tax, people that we want to conscript into an army, other places that we want to collect the revenues that make society better and possible? Boundaries between jurisdictions began coming together. Changes in grids and street names, types and directionals began to evolve. Addressing authorities didn't necessarily have all the information they needed, because they started with, stones on the roads, numbering lots and things like that. There was no need or requirement, no regulation to conform to stringent requirements. And so the systems evolved independently without the benefit of modern technology. And so we find ourselves in an interesting place as GIS professionals looking to focus on documenting the addresses that have already been created across multiple systems in some places, with the benefit of technology, having to sort out how we can manage and maintain high quality data about address locations that evolved independently. In the United States, addressing is determined locally, for better or for worse. Some entities do a real solid job. They're very consistent, very accurate. Other entities find it to be a necessary function instead of one that they're eager to perform, which leads to a patchwork of addressing systems and not sufficiently standardized. Then there's the public perception, as we discussed earlier, that addressing is a function of USPS. They think their zip code is actually a part of their address. Their zip code is important for USPS purposes, and it's become very useful for tracking the location for other purposes as well, but addressing is a function of the local government. Then there's no standard systems of records for addressing. Across the U.S., there are varying requirements in varying places to document addresses for different ways prior to NextGen 911, of course. This also lay over that patchwork of technology capabilities where you have some GIS haves, what I call haves, have somewhat or have nots, that are very capable of managing GIS, addressing in a GIS, kind of capable of managing addressing in a GIS, or not very well capable of handling and managing addressing in a GIS system. This being the case, we wind up with the situation that we're in today, where we have a patchwork of addressing systems and a patchwork of documentation that for those addresses in various places in various ways that, with the advent of NextGen 911, need to kind of come together, become standardized to some level, and then be used for delivering 911 calls to the right PSAPs. We'll talk more about that in just a minute. At this point, I'm going to turn it over to Annie, and she's going to tell us all about the anatomy of an address.
Well, it's a good thing we're talking about addresses and not hearts, because I couldn't help you there. So, so we're going to talk about the anatomy of an address and who thought it could be so very involved. So really, the goal of an address should be geared toward public safety usability. Okay, we want to make sure that we're creating logical addresses so that our emergency responders can efficiently and effectively find a location in an emergency. And in order to do that, we have to have a comprehensive, cohesive, logical numbering system. You can have multiple addressing systems used within a locality. I think back before the county where I live, before we did our major readdressing in the 1980s, I think there were at least 5 or 6 different numbering systems being used at the same time. So you can only imagine how difficult that was for emergency responders, which kind of prompted the whole change to E911 addressing. So do we want to put out a question, Jeff, and ask what address system everyone uses? I don't know, is that one of our polls?
I don't think we got any polls in this one, sorry.
Okay. So yeah, there can be different addressing systems, and just wanted to ask, which system do you guys use? Does anyone know, or do you just kind of go with what's been done and you don't really ask any questions? Anyone?
Gary Bates says
MSAG?
MSAG, Master Street Address Guide. Anybody else? Let's see. We got some chats here. MSAG, can you repeat the question?
Yeah, which address system do you use? When you go to assign an address in your community, what reference do you use? How do you assign that address? Address grid system?
Grid.
Nice.
There you go, mile markers. Distance-based, 1,000 addresses per mile.
Nice.
That's
okay. Good. Thanks, guys.
Little system. We got some real pros here. 5.28 foot. How about that?
You can definitely tell who does the addressing in this group.
That's right. Multiple grids. Now there's a complicated situation, multiple grids. I'm sure you're going to get into that. Okay.
All right. Thank you, guys. So again, just to reinforce, we need to have something that's easy to comprehend. Kyle, I saw you. That's funny. Ask our planning department. That's a good one. So we need to have something that's easy to understand and comprehend, definitely something that's logical, and something that's easy to update and maintain for sure. So really, there's two main types. There's address system grids, okay, and grids can come in different forms with different types of measurements. And then we have distance-based addressing, where you have X number of addresses available every X amount of road space. You can also have a combination. In a lot of localities that are more urban, it makes sense to use a grid-based addressing system where you have blocks that are closely located together. But then in a more rural situation, it might make sense to use the distance-based addressing. But then for some communities where you have a good mix of urban and rural, it might make sense to use a combination of both of those.
And Annie, I would say that where you find a combination of grid and distance is more that sort of zone of convergence where you find the urban setting moving into the rural setting.
Yep.
And there's kind of this, sometimes a clash of the two systems, particularly where you have really highly populated areas like where I live in Southern California, and city boundaries bump up against other city boundaries, and there is sort of this history of distance-based, but then you wind up having multiple grids come together, and you find some trouble in those zones of convergence.
Yes, definitely. So with the grid system, you're getting a northern and eastern coordinate system, and the numbers do tend to be really large. I've seen them as high as 6 numbers before. Again, it works the best for localities where you have more straight roads, because roads that are very curved, it can cause a lot of issues. Number one, it can cause your addresses to actually be out of order. But then if you don't take into account the road curvature, you can actually run out of addresses too. And I've experienced that with the localities that I've worked with, is they've actually started to run out of addresses because the curvature of the road was not considered when the grid system was implemented. And this is just a quick graphic showing, again, that it's ideal to use the grid system for straighter roads as opposed to ones that are more curved. Jeff, did you have any more input on this grid?
Not really. Grid systems, this is a good demonstration of grid system. It can lead to some complicated addressing, as you kind of see along the loops there, which you kind of talked about with curved roads. But you have to be careful with grid systems if your streets aren't well aligned to the grid like we see here.
All right, so distance-based addressing really is essentially you have a number of addresses that are available per X amount of road space, right? So we see those in increments, and you can either have them in feet or in miles. The most common increment that I see is the 5.28 feet. With localities that I work with, I see a lot of people using that 5.28 feet. When we talk about parity, we're talking about the occurrence of odd and even on the appropriate side of the road. So the side of the road being when a vehicle is proceeding along a route, it's basically going in the direction of the numbers ascending. So you're going to start on the road at lower numbers, and the numbers ascend as you go down the length of the road, with the odd numbers on the left and the even numbers on the right. Now, an address number should be assigned to every structure that's inhabited. Now, that doesn't mean that, it's just someone who's living in that structure, okay? We want to take a look at other structures as well. So not only homes, businesses, schools, college campuses, hospitals, et cetera, but what about areas of recreation? What about park pavilions where people will congregate for family reunions or for activities? We need to take those things into consideration as well. Lots with multiple structures need to be dealt with by subaddressing or using multiple house numbers. I will say from experience that subaddressing is one of the most mismanaged aspects of local government addressing. And it's not a fault of the municipality. It's really a function of people are making up their own addresses. What do you do when you live in a 300 or 400-year-old city and you have just no available addressing? People start making up stuff, or they put alphanumerics, or they use half addresses, and people really have to make do, but that information is not always communicated back to the municipality. Okay.
Well, and this is where that USPS relationship gets funky sometimes, right? Because
yes.
USPS will accept an address that the municipality hasn't put out because their business, again, is making sure that the right people get the right parcels and envelopes, and
yes.
it's good enough for them. And all of a sudden it becomes a de facto address when, in fact, it never existed in any government system.
Yeah, and I've heard, and I don't know if this is true, but I've heard that legally, if they know where the delivery is supposed to go, they have to deliver it, even if the address is incorrect. So it's really good when you're a locality, when you're an address manager, to work with your post office. They can be your biggest advocates. They can help you fill in any missing addresses. You can help them clarify any errors in their databases. It's very important to have a good relationship with your post office. Corner lots. Corner lots are interesting because a lot of times they can present themselves as a front door that faces one street and a driveway that actually comes off of another. And in many cases, those driveways will have garages, and you have to look at it logically. An emergency responder is generally not going to gain access through a property via a garage door. So it makes sense, and the smart thing to do is to assign the address based on the front door location. So that's another consideration. We can go to the next one now. So here's our typical postal address format. You have an address, the street name, the suffix type, and then you have the city, state, and zip. That's what we think of as an address, right? We don't really think much more into it than that. But indeed, for addressing for NextGen, it gets a lot more detailed. So some best practices: you want to avoid super long address numbers. You want to avoid the half addresses. I know in a lot of circumstances it's unavoidable. You also want to avoid using a combo of alphanumerics and hyphenated numbers as well. Also want to avoid leading zeros, which I've never personally seen that, but I'm sure it exists. Also avoiding single letter road names like B Street. You also want to use the common sense addressing, which is east to west and south to north. And if you have two addresses that adjoin or two road center lines that adjoin creating a loop, then you want to make sure the addressing follows the same direction logically so that you don't have any anomalies that occur on those center lines.
And of course, we have to acknowledge that these are like if you were starting a brand new addressing system in a vacuum, these are things you could do. But everybody already has kind of grids and systems set. And so if yours doesn't number from east to west or from south to north, or you have single letter street names, or you have, God forbid, directional names in your street names, or things like that, everybody has kind of like the situation at hand, and you have to work through those.
All right, so this is just a really good graphic of how we should use these best practices in real life. When you have a cul-de-sac, you want to make sure that you are obviously with your odd numbers on the left and the even numbers on the right assigning your addresses, okay? And they're going to start in ascending order based on where the street starts from the main road. So Davies Court starts at number 1 and it ends at number 13. So your left 2 is 13. And then for a through road, it's very similar. You just want to start where, like from Narrows Road, where it begins off of Baggett Road, you want to start at number 1 or 100, however you're doing your addressing, and then just as you increase down the length of the road with your numbers ascending. That's basically the best practice. So the NENA recommendation is for every 5.28 feet you have an increment for addresses, which allows for 1,000 numbers per mile. This is the standard that I see for a lot of distance-based addressing in the localities in which I work. And the logical thing is really, it's really to make sure that people can kind of estimate where an address is going to be down the length of the road. Even if the number isn't posted, they can kind of say, okay, well, if I'm going to go to 500 Alpine Lane, I should be able to go about a half mile, and I should be in the vicinity of that address. So that's really the logic behind assigning addresses this way.
Yeah, and Annie, I want to step back for just a second because we have a good question in the chat on this graphic. Catherine says, so would the address range on the street center line only go up to 13 on Davies Court?
Sorry, I muted myself. I would say in this circumstance, generally when I see things like this, especially in cul-de-sacs, it's usually in planned communities. Okay, you have subdivisions that are, maybe quarter-acre lots, and you can do pre-addressing in these subdivisions and make sure that you have enough addresses. So in this circumstance, I would say yes, that would be the high number on the street. It is very important, though, to make sure that, this is why in a lot of local governments, people will only work with approved and finalized site plans and plats, because you don't want to get into a situation where you're doing pre-addressing and releasing those and then, oh, they've changed the plan. Yes, leave yourself room for addressing. On things like this, though, I would say 13 would be the high. If this was an approved site plan or subdivision plan and someone brought this to me and I did the pre-addressing, I would number it like this, or 100, 102, 104, 106, etc.
So I think part of the answer too lies in something we're going to talk about in a minute with the GIS management of addresses, because you're really asking the question, should this be an actual range or a theoretical range? Because one of our additional comments is we use a full range 1 to 99. And so there's pros and cons to managing your GIS data both ways. She also says, I just had an instance where I had to extend the range by 1 digit because someone assigned an address. How will this work if the street is realigned, but addresses have been already assigned?
Yeah,
so
and
there's some complexity to that situation for sure, but I think it comes down to a GIS management question as much as it does an address management question.
It looks like someone raised their hand. I just got a pop-up. I don't know if you can.
Yep. Let's see. I think I can see that. Let's see.
I can't. I just saw it pop up,
All
but
right.
I don't see.
Huh. Okay. Thanks for raising your hand. I don't know who you are. If you wanted, maybe it's in the chat.
David raised
his hand. If you want to add it to the chat.
Yeah, go ahead and add it to the chat, guys, or to the Q&A, because that's easier for us to see, and we can make sure that we touch on all of these at the end. So Brian says, where I live, it's not flat, but also not dense.
Let's do this. Let's just, because we have a limited amount of time here.
Yeah,
let's get through a little more of the presentation, and as I see things that are fitting to the part of the presentation we're in, I'll bring them out. And
okay.
If you have a particular question, don't forget, not only in the chat, but in the Q&A, we can answer it. We can type the answers as Annie speaks, and then we can also give you feedback after the session in that format as well.
Okay, thanks, Jeff. And thank you guys in advance for all of your questions and your discussion. This is really great.
By the way, this kind of conversation is exactly what we look to have in this workshop that we have, because there's always plenty to discuss in regards to addressing. So definitely throw them in the Q&A box. Keep sending stuff in the chat as well. It's all good stuff.
Thank you. Okay, so the addressing authority, you really want to use nationally recommended methods. You also want to try to take a regional approach if you can. That way you have some continuity and some consistency with your addressing systems regionally. Just makes things a little bit easier, especially as you cross through jurisdictions. It may also be beneficial to have an address review committee, especially when you have these subdivision plans coming in, when you have new communities being platted. This is all really good stuff. And also road naming standards. And just something to throw out there, how many of you are actually getting input from your 911 center about road names and duplicates? It's really important to have that input, because you want to make sure that you're not using any duplicate road names or ones that sound the same. Even if it's from one municipality to a county, if it's in the same zip code, then that can cause an issue for routing. Okay, so we can go to the next slide. I think there's more on this one. Yeah, so
Sorry.
Yeah, there you go. Okay, so for rural addressing, we need to take a look at the long driveways. So in a larger lot subdivision where you have, 2 to 25 to 50 acres, what kind of issues is that going to present? And you need to look at it from kind of two different perspectives, not just from the addressing perspective, but also from the CAD perspective too. What's going to be beneficial for your dispatchers on the other side? Should you maintain a file where you have access points that can be used in CAD to help people identify those access points to these structures? Also, how can you establish signage as well? The main thing here is that if you can't see it from an emergency vehicle, you can't see it. Okay, so you want to make sure that in these long driveway rural situations or areas where you have 3 or more or 2 or more structures that share right-of-way, you want to make sure that signage accurately reflects what's going on in the real world. Okay. Okay, so for urban addressing, especially with really old cities, you have compact address ranges. We also, now would be an appropriate time to talk about the actual versus theoretical address ranges. There is no right or wrong answer. It really just depends on the situation. Okay, when you have more populated urban areas, when you're dealing with block addressing, you could get away with using theoretical ranges. But when you have more rural situations, you might want to go with what's actually out there, because the addresses are spread farther apart. And it's also going to affect your fishbones when you start looking at the analysis that you're doing from a geospatial perspective. You also want to think about things like annexations. What happens when you live in a really densely populated city and you annex land in a more rural one? What is that going to do to your addressing system? So, Jeff, did you have anything you wanted to add on this slide?
Yeah, I just want to say, you make a really good point that in terms of GIS data management, and we'll get into that next in our next section, in the actual versus theoretical range, there's a really good conversation going on in the chat panel, kind of with the pros and cons of each. And you tend to see where theoretical makes a big difference because you have a dynamic, fast-changing address scene where there may be addresses being changed or added within the theoretical range to cover that. As you point out, actual ranges are often very good for geolocators in urban and rural areas, that is, because those long roads geolocators have a harder time with. So we'll get into that in the next section here, but you make good points there with actual and theoretical. Always a hot topic.
Oh, yeah. All right, so this is a really important slide because I feel like for address management, and in general, locality addressing, you really need to establish or understand who the authority is. who is your addressing authority, because that's ultimately going to determine how, why, and to what addresses are assigned. Okay, someone who is in public safety or in GIS, when GIS is very well connected with the world of public safety and NG911 and why we assign addresses, that's going to be a little easier in terms of making sure best practices are followed. But if you have a more irregular situation, like if your addresses are assigned by someone in public works or someone in a planning department, someone who may not be as in touch with addressing for public safety, it may cause some, not problems, but it just might cause a little bit of disconnect there, okay? Because for planning, for example, planners generally want to assign addresses based on parcels, okay, which is a very different business need than public safety, where we need to assign based on structures. All right, so that's a very big distinction that I like to make, and understanding who your addressing authority is, making sure that you're really breaking down silos in NextGen and having that communication is extremely important when you're working on assigning addresses. So for data quality actually encompasses a number of different things. Number one, we're looking to see if the data is available. Believe it or not, there are a lot of localities who still don't have an address points data set, which is one of the required layers for Next Generation 911. It's one of the required data sets. We need to make sure that all of the data is complete. Okay, and what does that mean? Well, it means that not only are you following the NENA standard and making sure that you have all the required fields populated in your schema, but it's also making sure that you have addresses that represent what's out in the real world. Okay, so do you have a college campus that has 15 buildings but one address? Think about that. What kind of problems can that present? Okay, so you need to make sure it's also accurate data. You need to make sure it's timely. Okay, and the most important thing is that you want to make sure the data is consistent across all of your systems. You want to make sure that you're not giving public safety data that's months and months old. Okay, it's incredibly important that our dispatchers and our first responders have the most timely, accurate, and complete data that they can possibly have. Do you have a maintenance schedule set up? Do you have an update schedule set up where you're updating and provisioning data into these different systems at regular intervals? All of these questions are important. And then, and you know, this is a whole other workshop, what I'm about to mention, but we also need to look at the data quality from a geospatial standpoint, okay, because there's many facets to data quality. It's not just the things that are here, but from a geospatial standpoint, validating the GIS data to make sure that it's accurate, to see if there's any anomalies. Let's take a look at the fish bones. Where are things out of order? Do we have overlapping ranges? And again, Jeff can tell you that's actually a whole other workshop that we do.
Yep, that's a fact.
Standards are important, and let's just roll right into the next slide there, Jeff. I want to make sure you have enough time for your case study. So the different schemas, obviously we have our own for local government. We might be using the Esri the local government model. You might have a different schema for your individual business needs. Obviously the CAD systems that you use in public safety require a certain type of data structure. And then of course, what we focus on is the NENA GIS data model. So I think the best thing to do would just be to briefly describe this so that you have enough time for your case study, Jeff. The CLDXFs, do we have enough time?
Yeah, no, I think you're right. Let's zoom through this. Because
there's so many.
Let's go high level on this, and we'll get through it.
Okay, so really, when we talk about parsing, what we mean is breaking something out into its individual elements. Okay, the address example that we showed a while back where everything was in a continuous string with city, state, and zip, that's all good and well, but that is going to be useless to us in NextGen 911. Okay, the CLDXF, which is a Civic Location Data Exchange format, is a NENA standard that describes how the data should be shown in GIS. Okay, and that actually supports call routing and dispatch in NextGen. okay, as well as the pivot flow, which helps query out those addressing elements and send that data along with the 911 call over the internet. All right, so the important thing to remember about the CLDXF is that it actually dictates how that data should be divided up in an address element and what that should look like, because we get so detailed, especially with address points, that we can actually go down to the seat level for next gen. So if you want to switch to the next slide, I don't know if it's on the next one. No, let's go to the next one. Yeah, so here's the street name element. So you have street name, the pre-directional, the post type, the pre-type. There's many different elements in a street name. Okay, so you can have directionals. Some localities don't use directionals. And then you can have post directionals, like in Washington, D.C., you have northwest, northeast, southeast, etc. And then for sub-addresses, again, you can actually get down to the seat level. And you'll have to refer and become very familiar with the NENA standard, and we talk a little bit more about this in our strategic planning for Next Gen 911 GIS on Friday. We'll talk a little bit more about that. But making sure that you're familiar with that standard so you know the data that's required, so you're not, racing around trying to add in all this extraneous data that you may not have. Focus on what you have and what you can do with what you can have based on the standard. Okay, and is that all for this one, I think?
Yeah, that's all. I do want to point out here, as we wrap this up and we head into the case study, and we have just a few minutes. So again, thank you. Still, lots of good discussion going on in the chat, so we want to continue to encourage that. And then I just want to point out on this slide that the granularity of these additional elements provides flexibility. All of a sudden, you have a different ways to kind of concatenate names back together for different systems via things like ETLs or extract, transform, and load scripts that allow you to do way more than you could before, and it allows you to address different departments' needs in the government enterprise different ways with the same data set instead of managing, maintaining multiple data sets to do multiple needs. This is something that kind of comes with pain to get into the granularity, but in the end, you'll find yourself only maintaining that data set one time, which is exactly what this case study is about, the master address database. And I have Yoda here because it takes a Yoda sometimes to take addressing data out of multiple sources and put them into a master address database. I want to share the case study of the city of San Jose, California with you, where the city auditor reported 9 addressing databases across the enterprise. And they found these islands of data, somewhere in the public works department, somewhere in the planning department, somewhere in the utility billing department, databases across the city, both GIS and non-GIS. They had 250,000 address points in a GIS database, and that was what they used as their starting point. We assisted them in this project, and we took those 9 data sets with the addition of a commercial direct mailing database, and we ran it through a process that we call address comparison and evaluation, where we identified additional address point candidates. 150,000 of them came out of those 8 databases plus the direct mailing database. There were addresses in those other databases that didn't exist in the master address database, which was this GIS database. We did a weighted analysis to indicate a trust factor or trustworthiness, essentially taking a look at what databases each address candidate came from, and if it occurred in more than one database, its trustworthiness factor went up. If it came from databases that had a high trustworthy factor, then the overall aggregate came up as well. But if it came from things like a voter roll, which has virtually no vetting, it only had a value of 1, as you can kind of see in the spreadsheet. But if it came from a database like the Alley, which has a high level of vetting, the 911 Alley, then it had a higher weight for that fact. In order to do this, we took these databases, parsed, normalized, compared them, and then we did this evaluation that we just discussed. After that, we geolocated the additional address points, and we put them in a master address database. All in all, we added, of those 150,000 points, 138,000 address points, which brought their total up to 268,000. Through that process, we actually found 20,000 addresses that were in their existing GIS database that were either duplicates or were replaced by sub-addresses. And what this provided for them was a robust database that captured a substantial majority of the actual structures, including a tremendous number of sub-addresses that were added for all of their business use cases. We immediately helped them with integration to a permitting system, and then they have planned to do other system integrations into this master address database as well. So effectively what they did was they wound up going from 12 FTE to manage 9 databases down to about 9 FTE to manage the master address database and others, and until the time, such time as they have been able to integrate the other systems into the master address database. Ultimately, their idea is that they'll wind up with 6 FTE managing this one database instead of 12 managing multiple databases. So it's a really good example of how you can find synergy from across the entire enterprise. It services not only those public works and planning and utility billing needs, but very much importantly, the public safety needs as well. So we really appreciate you joining us for this webinar session today. We have about 4 minutes left, and so if we have some time, we'll jump into a couple of these questions. But I want to make sure that everybody's aware, and this has been a question asked a couple different times, that this presentation will be available in the conference website and app for you to review. It has been recorded and will be made available as well. So we really appreciate your presence today and the discussion that's been going on in the chat. We're also going to comb through the chat because there has been so much of this. Great conversation. We're going to comb through the chat and answer any questions we can in notes on the conference website as well. So really appreciate your time today and your joining us. We want everybody to stay healthy and safe out there and socially distance yourself from everybody so that we can come together in person after this is all over and meet at an in-person conference someday. So thanks a lot, Annie, for joining us and your contribution. You did a great job today, and
Thank you, Jeff.
appreciate everybody's attendance.
Thank you guys so much for attending. We appreciate all of you. Stay safe, stay healthy.